In the early 1900s, a German high school teacher named Wilhelm von Außen believed that the intelligence of animals was vastly underrated. To prove his point, he set out to teach his horse, Hans, some basic arithmetic. What started as a simple experiment quickly turned into a sensation. Clever Hans, as the horse became famously known, learned at an astonishing pace. Soon he could add, subtract, multiply, and divide numbers, delivering spot-on answers by tapping his hoof the exact number of times required. Crowds gathered, scientists marveled, and for a while, it seemed like we'd unlocked the secret to equine genius. But it took more than a year for the truth to emerge. Investigators discovered that Hans wasn't crunching numbers at all. Instead, he was picking up on subtle cues from his owner's facial expressions, tiny nods, and gestures unconscious signals that told him when to stop tapping. This revelation wasn't just a quirky footnote in history. It shone a glaring light on a sneaky pitfall in science: experimenter bias or observer expectancy effect. It's the way our expectations can subtly or not so subtly shape the results we get, often without us even realizing it. At its core, experimenter bias happens when a researcher, intentionally or not, influences the data, the participants, or the outcomes of an experiment. We're human, after all, and humans aren't wired for perfect objectivity. Our brains are riddled with shortcuts, like confirmation bias, where we zero in on evidence that supports what we already believe, or hindsight bias, that nagging feeling that we knew it all along, after the fact. In research, these mental quirks can creep in during every stage, from how we design a study, to how we run it, to how we interpret the numbers at the end. The experimenter might treat participants differently based on hunches about the hypothesis, or structure questions in a leading way, all while convinced they're being neutral. The result? Flawed data that leads us astray, turning solid science into something unreliable or irrelevant. Think of it as a specialized flavor of confirmation bias, where the scientist's hopes and assumptions become a self-fulfilling prophecy. And once it takes hold, it can undermine trust in entire fields of study. One of the most famous demonstrations of this bias comes from 1963, when psychologists Robert Rosenthal and Kermit Fode ran a clever experiment on expectations themselves. They divided psychology students into two groups and handed each a batch of rats tasked with navigating a maze. To one group, they said, "These are your bright rats, super smart navigators, bred for speed." The other group got the opposite pitch. "Yours are the dull ones, genetically sluggish and bound to flop." In reality, all the rats were randomly selected from the same ordinary stock. There was zero difference in their smarts. Yet, when the students reported their results, a pattern emerged that defied chance. The bright rat handlers clocked their furry charges, finishing mazes in record times, faster laps, fewer wrong turns. The dull rat teams? Their rodents lumbered along, as if weighed down by destiny. No genetic wizardry here. It was the students' beliefs at work. They handled the smart rats with gentler encouragement, maybe held them steadier during trials, or timed them with unconscious optimism. Rosenthal and Fode's work didn't just expose bias. It proved how the experimenter, as vibe, can ripple through to the subject, warping outcomes in ways we can't always see. But experimenter-subject interactions aren't the only culprit. Bias can slither in at every phase of a study, from the brainstorming spark to the final write-up. Take design bias, one of the sneakiest forms. It strikes when a researcher locks onto a hypothesis and molds the whole methodology around proving it right, like tailoring a suit to fit only one body. Rosenthal himself crunched the numbers later and found that a whopping 70% of these biases tilt results toward the experimenter's pet theory. Then there's sampling bias, or selection bias, where the pool of participants gets skewed, maybe overstuffing it with one demographic while sidelining others. So your representative group looks more like a fan club than a cross-section of reality. Omission bias plays into this when entire ethnicities or age groups get left out entirely, while inclusive bias flips it, grabbing the easiest sample available, like quizzing only college kids in your dorm. The endgame? Conclusions that scream, true for everyone, but whisper, only for these folks. Procedural bias sneaks up in the doing of the experiment itself. Imagine rushing participants through a survey with a ticking clock. Their answers come out hasty and half-baked, masking their real thoughts. Or measurement bias, that systematic glitch during data collection. Faulty gear spitting out wonky readings. Or researchers mishandling tools in ways that nudge results one direction. Interviewer bias amps it up when the person asking questions leaks hints, subtle smiles, leading phrases that steer responses toward what they want to hear, echoing that clever Hans hoof tap all over again. And don't get me started on response bias, the participant side of the coin. People fib on surveys all the time, dishing out right answers or socially polished ones instead of the raw truth. It's amplified by the Hawthorne effect, named after factory workers who suddenly boosted productivity just because they knew eyes were on them. Observation alone flips a switch, making us perform like we're on stage. Even after the data's in, biases linger. Reporting bias, or selective reporting, hits when results get cherry-picked for the spotlight. Positive findings? They flood journals, snag citations, and shape policy. Negative ones? They molder in drawers, unpublished and forgotten, even though a no effect can be gold for science. It's often beyond the researcher, as direct control publishers chase the shiny stuff, but it starves the field of a balanced diet of evidence. All these threads weave a tangled web, reminding us that bias isn't a villain in a lab coat. It's the shadow we all cast. So, can we ever banish experimenter bias entirely? Spoiler, not completely. As long as humans touch the process, with our upbringings, educations, and experiences tinting every lens, some color will bleed in. But we can tame it, corral it, make it a whisper instead of a shout. Start by shining a light on it. Educate your team early and often about these pitfalls, so everyone's eyes are open from day one. Build diverse crews. Two folks from different backgrounds bring fresh angles, sparking debates that ferret out blind spots. The bigger the circle, the more voices challenge assumptions, turning potential echo chambers into lively forums. And weave bias checks into every step, from hypothesis tweaking to data crunching. Pause and probe for skews. Modern experiments arm themselves with smart safeguards to starve out distortion. Proper training turns rookies into bias spotters, while crystal-clear protocols, step-by-step playbooks, keep everyone on the same impartial page. But let's dive into some heavy hitters for dodging the bullet. First up, blind analysis. It's like playing detective with your eyes half shut. Withhold key details, the hypothesis, the expected outcomes, even the raw results, until the crunching's done. Analysts plow through blind, free from preconceptions that could sway their math. Flip it to the participants. Keep them in the dark about the study's aim so they can't tweak behaviors to help along. Even better, go double blind, the gold standard in clinical trials. Here, neither the researchers doling out treatments nor the patients receiving them know who is getting the real deal versus a placebo. No winks, no expectations, just pure, untainted reactions. It nukes design flaws and interviewer nudges in one go. Another powerhouse move: slash interactions between experimenters and subjects. The fewer cues flying those micro-expressions or tone shifts, the less room for influence. One slick trick? Pre-record instructions. Hit play on a neutral voiceover, and poof, human element minimized. Responses stay unswayed. Finally, cap it all with peer review, at rigorous rite of passage. Fellow experts, armed with the same chops, dissect your work for cracks. Does this sample skew? That procedure smell fishy? Their outside gaze catches what yours misses, polishing the study until it's publication ready and rock solid. There you have it, a whirlwind tour through the wild world of experimenter bias, from a tapping horse to maze-running rodents and all the sneaky shapes it takes along the way. We've seen how it creeps in, wreaks havoc, and most importantly, how sharp minds have forged tools to fight back. Science isn't about perfection. It's about progress, about building walls against our own flaws. Next time you're knee-deep in data or doubting a headline, remember clever Hans. Truth often hides in the cues we don't even know we're giving. Thanks for joining me on this deep dive. We hope it sparked some aha moments and armed you against the biases lurking in every experiment. If it did, hit that like button, subscribe for more myth-busting science stories, and drop a comment. What's the wildest bias you've spotted in real life? See you in the next one. Stay curious, stay skeptical, and keep questioning the hoof taps.